record. That is the big picture. So dalam kita punya ni pun, kita bagi kepada dua, nanti kita akan guna stochastic method dan kita juga akan guna deterministic method in modeling. Okay. So last time kita buat apa? Kita buat we need to make a connection between the variables. So far apa yang kita buat adalah kalau kita ada satu saja variable dia tak menjadi. So in order to model something, you need to have at least one independent variables and at least one dependent variables. And usually it's just two between these two, because if you include more than one, then it will be much more complicated, and you need to take into something that is called submodel. Guna submodel and then kita bahagikan kepada beberapa model. So mathematical model is a visualization of real world problem, just a visualization. It's never a completely accurate. It never accurately covered. Even though, for example, experiment is also never a completely accurate. Dia mesti ada error kat mana-mana. Any model has limitation, and the good model will provide variable results that you can interpret and conclusion that you can use. What does it do? What our mathematical model is doing is to construct and design to study real world problem or behavior of interest. For example, climate change, spread of disease, like what we did during this pandemic, mechanical failure. For example, you can see, is it really a mechanical failure or is it from some external force? Okay, so you can see, because in my case, I usually study the something about physical stuff, physical behavior. So something can be naturally happen, or something can be happen by force. So it's either two. And it is also help to understand the behavior better, or to predict and plan something in the future. So for example, if you have seen something like criminal minds, or something study about criminology and so on, that is also, if you study more, then they also use mathematical model in order to catch the culprit. Contoh yang saya paling suka satu lagi, ada satu cerita tu, nama dia punya nama tu numbers. Based on numbers, try to catch criminal using mathematics. Dia tajuk dia macam ni, numbers.
Dia suka cerita tu juga.
Yang ni suka Sekarang dah tak ada kat TV.
Nak cari tak jumpa dah sekarang.
Tak ada, susah nak cari. Tapi best lah. Dia punya ni, dia based on numbers. Ada satu lagi soalan, apa ni? Satu persoalan dari saya ingat dia punya dialog tu, dia kata, which one is easier, to construct a question or to construct the solution? Kita nak buat soalan lagi mudah atau kita nak solve lagi mudah? Salah satu, saya tak ingat cerita apa, tapi dia quotation tu daripada katanya daripada dalam cerita tu, dia daripada profesor mathematics lah soalan dia. Dia tanya student dia, sama nak buat soalan lagi mudah, lagi susah, ataupun nak menjawab soalan lagi susah. Okay, and I think I have told you about this, the cycle of mathematical model. So first of all, we always start from real problem. Kita start daripada real. Kita selalunya memang macam tu. Kita tak ada macam something that is not existed. Kita tak boleh nak buat semua benda yang tak wujud, kita tak boleh nak explain. So we take anything from real problem, then simplify by, saya ulang balik, simplify by taking assumption. Taking assumption. So for example, if I'm going to model how many second it should be for us to apply the brake before the car will stop. So this is like a car braking problem. So kalau ada satu kereta dengan kereta kat depan, berapa banyak masa yang diambil untuk kereta tu berhenti dengan sepenuhnya, dengan laju tertentu, dengan jarak yang tertentu. So tu salah satu contoh, satu model yang kita nak buat. By taking assumption, what does it mean by that, taking assumption? Contoh, kalau kita ambil semua jenis model kereta, contoh kereta kancil, Hilux or bus. So kita ada banyak, we have a lot of factor to consider. But what if we just assume there is one category of vehicle, just one category? You don't have to get every category of vehicle. So just make take an average of their friction, or average or their weight, of their mass, and so on. So just take assumption that we just say that everything, and then just plug in, take the average. So that is another example, an example of taking assumption just into one category. And another thing is, you can say different road has different friction. Jalan yang berbeza, dia punya friction, dalam bahasa Melayu geseran. The friction energy is different. For example, if you go to the highway, it's different than the mountainside. So in that case, you need to make sure that you choose your model properly. So just take assumption that this is usually people are speeding on the highway, so it is better to take model based on the highways and so on. So taking assumption that you need to go into the detail. That means that you don't have to go into the detail, just discard whatever that is not important. Take only what is important to your problem, the big problem, the big factor that will affect into your model. And then you model. How to model? So you need to have your variables. Okay, variables. Let me give you one example using the same example. Braking distance. How many times? What is the safe distance between car number 1 and the car at the front? Okay, what is the safe distance, something like that. So I can say the variable should be something like velocity, and then what I want is the distance. So what is the relationship between the distance, I can say, and the velocity. Or I don't want to use velocity, I think it's better to use speed. Okay, apa dia punya relationship between the distance and the speed? Is it, if it's the speed is high, is it the distance should be wider, and so on? Okay, so you need to consider the variables, two variables, one independent and another one is the dependent variables, and find the relationship. So bila kita dah dapat relationship, we need to do the analysis. So analysis, you can have number 1 from the data. So this is from your, also from your classical mechanics. So meaning that the physical theories, existing theories, if we have. Okay, so you can have two. One is you can use data, so that's usually from stochastic, and you can use existing theory, make some conclusion from this, and then interpret the conclusion, predict, and then explain. And then if you want more, you can add more factor inside your problem, make into a sub model, and then put it into the main model. So this part is what you need to work on first. How to simplify, and then what are the relationship between the variables. Okay, now let's see some, this is a good one also. I think this is a good philosophical interpretation of this guy, Pierre Simon Laplace. Dia kata apa? Dia kata, according to determinism, if someone, the demon, knows the precise, you can also same thing, also about human as well, knows the precise location and momentum of every atom in the universe, their past and future values for any given time are entailed, then you can see this. They can be calculated from the laws of classical mechanics. So meaning that if you know their past, then their future values can be calculated. So that is one. Yeah, it doesn't mean like this is like a prediction of the future. Like how did they predict the weather? How did they predict something? That catastrophe is going to happen, and so on. So it can be calculated, but nobody actually, this has not been proven because nobody can know about this one, every atom in the universe. We don't know that. It's impossible. All right, now first thing, the first step is to simplify. Most models simplify the reality. It doesn't make things complicated. Simplify the most thing. When you see you want to model, does it simplify your problem? Sekejap saya nak tengok. Saya takut seorang lagi ni lupa. Okay. Simplify reality, and in general, model approximate real world behavior. The key word right here, approximate, never explain in full, but it's just approximate. And simplification requires relationship between the variables that I have just said before, and this is called proportionality. In our case, we firstly call it as proportionality because this is the easiest relationship between two variables. This is the easiest, the basic relationship between two variables. Okay, and I think I've said this last time. So if you have, in our case, we use a positive key, y equals to kx. You can have kx plus a constant as well, but so far we use, that is another, it's not quite proportional because if you have y equals to kx plus, let's say, some constant, this is not a proportional. This is not the definition of proportional. Proportional definition is just y and x and a multiplier with that. This is something like, so this is not proportional, but it's somewhat proportional, and you can use it as a submodel. We can discuss this later on. Okay, so the key point right here is this one, y equals to kx. So it's like a constant multiplier of the other. And remember, in our case, we say that k is a non-zero. It's not a zero constant, meaning that it can be a negative as well. It can be a negative constant. And we write this, y is proportional to x, directly proportional. Y is, if we say y something like this, we call it as indirectly proportional. Something that is increasing, the other one is decreasing, and vice versa. Compared to this one, if x is increasing, y is also increasing. So this is direct proportional. Graphical interpretation. So for example, if I say y equals to kx, let's say k is positive, and you can understand that you can have as many as linear line as possible, as long as what? As long as it's not a straight line. The key point right here is as long as it goes to the origin. Lines that goes go through origin. So it is like a line that goes to origin. Same thing if we have y equals to kx, and let's see this one, and k, same thing, kx, but k is less than 0, so it's going to be in this line. A negative multiplier. So the key point, it goes to the origin. You start from 0, 0 in the Cartesian coordinate. Okay, let's see a simple example. Spring mass system. So you want to see, we want to see what's the relationship between the elongation of a spring, something kita stretch spring to, and the relationship between the mass, jisim dia tu, jisim pemberat. Okay, so we do some example, we do some experiment and take the data and then plot the graph. And what we get is this equation. The elongation is just some 16 over 1,000, 1, 2, 3, 4, 1,000, 10,000, I think, 1, 2, 3, 4, yeah, 10,000 of the mass. So elongation by that. So if you look at this one, because y 0, when it is 0, the distance is 0. When m equals to 0, meaning that no mass is attached, and then y equals to 0. Or I can say not y equals to 0. The elongation is 0. So that is our initial value. So we need to start our line from 0, 0, and then right here. So you need to also consider this value, even though it is not stated in the data right here. It's not stated in the data, but you need to understand that because this is a proportionality, you need to take into the account of that point, 0, 0. And there are many ways to do this. You can use numerical interpolation using cubic spline and so on. But this is a very easy example. You can just use a ruler or something, or you can use Excel function. Boleh guna yang Excel function tu, kita boleh approximate the value and then you see this results. So you understand also this is a basic one. So this one is just the slope. So K is just the slope. So the elongation of the spring is some constant, a constant multiplier of the mass. The heavier the mass, the longer it will stretch. And until some point, it will break the elasticity behavior. Lama tu dia akan putus. So ataupun lama dia akan jadi strict. Dia tak boleh nak patah balik kepada keadaan asal. Itu nama dia spring failure. Kita tak boleh nak ambil. Bila spring itu melepasi tahap tu, so kita tak boleh nak ambil lagi dia punya data sebab data akan jadi error. We just take that value until dia stretch, betul-betul stretch. Okay. So first of all, proportionality, in order to find the proportionality, you can see from here, the slope is the change. So the slope is the change of the values. Okay, now, pendekatan kita yang pertama, kita kata proportionality. How to find the proportionality? We need to find what is the future value what is the change of that value. How to find the change, the future value minus the present value. Or you can also say, you can also change this because change. You can also say present value because you don't know the future. Let's say present value minus past value. That is going to be an equivalent definition. Okay, and then get the trend of that change. Get the trend of that change. Collect the data over some time and then plot it. And if the behavior is taking place over a discrete time period, you call it as difference equation. And if the behavior is taking over a continuous time period, this is called differential equation. So for example, if I say difference equation is something like this, x n plus 1 minus x of n. So I define this as delta x. Okay, so this is the difference equation. And it's not yet difference equation because this is not an equation yet. I can say something like this: x n plus 1 equals to x. Change this xn xn plus delta x. Okay, now this is a difference equation. So I want to find the future value. This is just some current value plus the change. Differential equation, this is what we are going to learn in the next half of the course. But first of all, we are using a difference equation. Let's see some definition. Consider the sequence of A0, A1, A0, A1, A2, A3, and then until AN. Okay, so the first difference is A1 minus A0. So this is these two. Second difference is these two. And the third, and so on. So this is what? A0, the difference of that. This is A1, change in A2, and so on. So if you do this, the sequence, and you can see that the nth difference is given by this equation, and n is a positive integer. Positive integer, not the real values, not real numbers. It is a positive because it refers to the sequence. Okay, now what does it mean by that? So this is the future. This is the time period. So the x-axis is the time period, and then the an is the value that is changing over the time. Okay, so in our case, if we are taking just one difference between n plus 1 and n, so the time period is only 1. So the slope right here is changed with respect to 1. The change in A with respect to the change of time period of 1. So that's why we get this equation. An equals to an plus 1 divided by minus an. And you can see that the slope is just a sub n for one time period. It's not for the whole time period. You can see that this is invalid. For example, if I take this one, if I have another data right here, let's say this is an plus 2, okay, so the slope right here refers to the particular slope right here. It's not, this will be different, this might be different than a slope of an plus 1. So the slope is going to change. So meaning that if you know the value right here, kalau saya tahu value kat sini, saya hanya boleh tahu yang masa yang ke depan yang satu saja. Kalau saya nak tahu yang ke depan satu lagi, saya tak dapat. Saya tak boleh nak expect the values. So that is one of the disadvantage of difference equation. Sebab kita terhad kepada masa yang selepasnya. Selepas-lepasnya kita tak boleh nak buat setakat ini. Dia ada cara dia, nanti kita tengok macam mana. So kalau contoh saya duduk di sini, kalau katakan saya berada di sini, saya hanya boleh bercerita tentang kat sini sahaja. Kalau saya nak cerita pasal orang yang berada dekat AN+2, tak boleh, invalid sebab dia punya slope tu dah jadi lain. It can be a different values. Okay, setakat ni ada soalan?
Tak ada.
Tak ada kan? So direct to the point, I think. Okay, now let's see. Consider a saving account. Consider the value of saving 1,000. So you put 1,000 initially, and the interest is 1% for each month. So for the whole 1 year, it will be 12,000 at 12%. So what you can do is the sequence for each month saving is 1,000. So this is number 1. And then tambah dia punya apa ni? Tambah dia punya interest the next month. Kemudian tambah dia punya interest daripada sini. Jadi macam ni and so on. So awak boleh kira lah dia punya ni, dia punya sequence dia. So tambah 1%, 1% for each month. Okay, and you need to see the first difference. Kita nak tengok dia punya sequence of the first difference, second difference, third, and so on. Okay, so kalau kita buat ni, we can see that the first difference is 10. So the second difference is the previous, the current minus the previous, this one, and this one. And you can expect that the next will be 0.30, 0.40, and so on. So you can see that the change, the increment is quite constant. So the change in the sequence, you can see that this is the interest rate for each period, which is 1%, which is right. This is just 1%. Okay, so in short, what you can say that for every time frame, you can say the interest rate, the change in that particular time of frame equals to the interest rate times the current saving account, the current saving values. So if we want to find like the formula for the next one, so you can just rearrange this. So rearrange this one. The future value you want to find, remember what we want to find is the future value, what we want to predict. So just put AN on the right hand side right here. So I just putting this one to right hand side. So sebab tu saya dapat AN plus the current value times the change. So remember this is the future equals to present plus change. So and then A naught is 1,000 and is a positive value. So you can see that you need to know the previous value before you go for the next value. You cannot just jump nak kita nak apa ni kita tak boleh nak tahu contoh saya bagilah kan. Based on this one, based on my based on my first initial saving amount, it's hard kalau guna formula ni, kalau based on this formula, okay, based on this formula, it is impossible to find, let's say, after n equals to 10 years. Okay, so after n equals to 10 years, in order to find the value, you need to do this calculation by iteration 1, 2, 3, 4, 5 until 10 years. So you cannot just plug in into the formula and then get the value after 10 years at this point. So yeah, I think, but this one is easily done in Excel, or you can also do this in MATLAB or Maple and so on, or C++. Okay, soalan saya. Programming apa yang awak guna? Programming language, Maple ke, MATLAB ke?
Sekarang mostly Maple.
Apa dia?
Sekarang mostly Maple. Tapi dulu pernah je masa degree guna MATLAB dengan C++.
Excel pernah guna?
Excel tak familiar sangat lah.
Okay. Apa ni, kalau ikut dalam course ni, saya lebih suka guna MATLAB. Sebab apa ni, dia ada features. Dia kalau kita nak export data tu, bagi saya bagi mudah. Sama juga dengan Excel. Excel pun kalau nak export data, bagi saya lah. Cuma kelebihan Maple, dia senang nak buat algebraic manipulation.
Sebab kelas lain guna Maple. So macam banyak guna Maple je lah. Mostly sekarang.
Okay, tak ada masalah. Sama kita belajar banyak programming, tak ada masalah. Okay. Difference equation. Let's see some example in the dynamical system. So in the dynamical system, we have an infinite set of algebraic equations. So kita ada banyak set of algebraic equation, and it allows us to understand the change from one period to the next. Like I have said just now, dia daripada satu ni ke the next period. Dia bukan yang melampaui dia punya 1, 2 and yang kat depan lagi. The value of the next term is calculated from the previous term in the sequence, but you cannot find the specific term directly. Tak boleh nak ambil dia punya tu dapat directly. Contoh yang saya bagi tadi lah. We can also change the difference equation if we allow a constant withdrawal for each month. Okay, contohnya, saya masukkan 1,000 setiap bulan. Saya masukkan 1,000. Tapi dalam masa yang sama, dalam sebulan tu, saya juga boleh keluarkan duit sebanyak RM30. So now the nth change has become delta n equals to the rate. This is the original change minus the withdrawal. Okay, sebab tu kalau awak ada saving account, kalau boleh jangan, kalau saving account yang contoh yang saya tak kisahlah, kemungkinan dia syariah compliance ataupun dia conventional saving account, dalam setahun tu kalau awak nak dapatkan banyak dia punya percentage of interest, dia punya rate dia tu, jangan keluarkan setiap bulan tu, jangan keluarkan. Sebab apa? Contoh, kalau awak tak keluarkan, contoh saya tak keluarkan, kalau tengok kat sini lah kan, kita nak apply to the our current yang apa ni, current situation, okay, situasi kita, tolak RM30, katakan bukan 1,000 lah, katakan 3,000. Tolak apa dia, duit nak kena bayar PTPTN, duit nak bayar, saya tak pastilah PTPTN kena bayar ke dia kena deduct daripada ni, saya tak pasti. Tapi so contohlah saya bagi nak bayar bil, nak bayar kereta apa semua kan. So the change is So you can see that your change is going to decrease. So kalau mungkin awak boleh try, boleh cuba dalam setahun tu cuba jangan keluarkan duit dalam saving account. Simpan tempat yang awak boleh kacau. Ada satu account ni yang account awak tak kacau. Biarkan dia berkembang. Tengok macam mana. Betul tak macam yang dia claim the rate for 1 month or the rate for 1 year. Saja je. Ni nak tengok betul ke tak. Okay. Sama juga macam macam mana orang nak kira dividen apa semua kan. So kalau boleh dividen SASB, dividen tabung haji ke contoh. Kalau kita tak keluarkan, benda tu akan dikira based on your average amount for each month. So dia tak kacau, susah. Senanglah sikit orang nak bagi. Kalau tak, dia agak panjang cerita dia. That is just selingan saja. Okay, mortgage. Mortgage, apa dia mortgage? Mortgage kalau awak ingat daripada financial mathematics, mortgage ni contoh yang paling mudah, kita nak bayar duit rumah. Okay. So kita bayar duit rumah sampailah kita punya hutang tu jadi kosong. So kita tak bayar hutang. Duit rumah tu habis dibayar. Contoh kalau kat Malaysia maksimum adalah seingat saya 35 tahun. Okay, so if you take that maximum values, you can see that how much they charge for the interest rate and then how much you have actually paid. Macam mungkin misal. Alright, yang tu sama saja selingan. Alright, 6 years ago, example, 6 years ago, your parents purchased a home by financing 80,000 for 20 years. So 80,000 untuk 20 tahun. This is in US dollar by the way. Kalau tukar kepada Malaysia, dia akan jadi 320,000 for 20 years. And paying monthly payment, $880 bucks. The monthly interest rate is 1%. So therefore, per year, it will be 12%, agak tinggi. They have made 72 payments and wish to know how much they owe on the mortgage. So, dia nak tahu, dia dah buat 72 kali pembayaran dan dia nak tahu berapa yang dia berhutang. Sebab apa? Sebab they are considering paying off with inheritance. So, dia nak bayar dengan duit yang pusaka yang diorang dapat lah. So, 72 kalau ikut ni, maksudnya ni secara bulanan. 72 payments, but this is 20 years. So 20 years, kalau kira dalam bulan, that is going to be 240 months. So 240 months should be minus 72, contohlah seperti ini. Ataupun they could be considering refinancing. Depend on the length of the payback. Apa maksud refinancing? Kemungkinan dia refinance, dia nak singkatkan dia punya how many years. Contoh 20 tahun, yang asalnya 20 tahun, kemungkinan mereka nak tahu kalau dia orang bayar tu berapa, dia orang nak singkatkan kepada 10 tahun. Itu maksudnya. Dia 10 tahun ataupun 15 tahun. Ataupun mungkin dia orang nak cuba kurangkan interest rate. Contoh, kalau dia bayar 1,000, interest rate dia lagi kurang. Contoh saya bagilah. Okay, and then the change, what we want to know is how much they owe on the mortgage. Berapakah kalau katakan 10 tahun tu berapa mereka ada hutang lagi. Kalau dalam 15 tahun ada berapa lagi hutang, macam itulah. Okay, the change in the amount owed each period increases by the amount of interest and decreases by the amount of payment. So the change in the amount owed, kalau yang kita hutang tu, increases by the amount of interest. Sebab dia interest tu 1%. and decreases by the amount of the payment. So the change, apa maksudnya kalau kita buat ni, change of apa ni yang dia berhutang, change of apa ni, change of money, let's say something like that, change of amount owed. So this is equals to increases by the amount of interest. So increases by interest and decreases by payment. Okay, so apa yang kita faham? So let's try to apply this. So delta P, this is the balance. Ni lebih tepat. So the balance is equals to the current, the future value minus the current value. This is the future and this is the present. So last time we know that the change is the interest rate times the current value. So this is the payment. This is the interest rate. Yang ni apa dia? Yang ni this is not the same thing. Yang ni bukannya, yang ni yang kalau awak tengok dekat equation ni, yang ni bukan bermaksud yang ni tau. It's not, doesn't mean like that. The whole thing means this. The whole thing right here means this. Without the payment, kalau saya tak bayar, contoh saya tak bayar 2-3 bulan saya tak bayar. So you can see that the balance dia lagi tinggi, 0.01. Tapi disebabkan saya punya pembayaran, dia akan jadi berkurang. So the change right here is increase by the interest rate, decrease by the payment. Okay, so apa yang saya nak apa yang saya nak capai dalam kat sini adalah the future value that I need to know. So just change this, rearrange this. So Bn, B sub n, put it on the right hand side, and this is what you get. Not this guy, this one. Okay, put it on the right hand side, this is what you get. And my initial amount that I owe is 80,000. Yang saya berhutang asal-asalnya adalah 80,000. Alright, and then apa yang saya perlu buat? So I need to do this B0, B1, B2 until 20 because I'm going to have 20 years. So you can do this in your programming language, any programming language. Okay, and you can see that after berapa tadi? 240 kan? 240 bulan, this is the month, then the value is going to be 0. This is no hutang or debt. Okay, so you can see that it looks something like this. Just plug in. That's why kadang-kadang saya apa ni? Saya lebih suka guna Excel kadang-kadang lah, tak semestinya, tak semua. Tapi untuk for simple calculation like this, I prefer to use Excel. That is my preference. It's not a problem for you to use any other method. Okay, so kita tengok. So bila kita buat macam ni, when you do something like this, let's say 72 months. 72 months is somewhere in this time frame. So this is 72 months. Okay, so you can see that the amount that you owe, that the parents, these two owe, is somewhere in between 70,000 and 80,000, somewhere in between that. And this is the rest is the balance right here. Awak boleh juga guna cara ni untuk cari contoh mungkin if you want to test whether or not the amount of interest rate for a car loan, okay, try to find whether or not this is true. Sebab bila kita buat calculation ni, dia akan ada decimal error. Is it going to give that decimal is going to be advantage for us, or is it going to be an advantage for the bank? So kadang kalau awak kira dia punya ni, dia ada titik perpuluhan tu, apa ni, dia ada sen-sen tu. Okay. Kalau bank yang okey, dia sen-sen yang ada sen percentage, katakan awak berhutang dan buat personal loan selama 10 tahun. Okay. And then you find the interest rate. Okay. Kalau awak buat ni, tiba-tiba pada tahun yang ke-10 awak dah bayar habis semua, tiba-tiba dapat duit balik. Kemungkinan akan ada jadi macam tu. Sebab apa? Sebab dia ada sen-sen dia tu. Kalau bank, setengah bank yang okey lah, setengah tu dia buat senyap je. Kalau bank yang okey, apa dia buat? Dia yang terlebih kita bayar tu setengah, contohnya kita masuk guna apa? Guna CDM, cash deposit machine, harga sebenarnya 599 kita punya amount yang kita kena bayar kepada bank. Tapi disebabkan cash deposit machine dia tak terima RM1, so kita genapkan kepada 600. Okay. So dalam kes ni, ataupun ada sen-sen lagi lah. So dalam kes ni, you need to be careful. Bila nanti tahun yang terakhir awak nak bayar tu, please check, tolong check apa ni, amount yang awak berhutang tu ada lebih ke tak ada lebih. Sebab kadang-kadang setengah bank ni dia buat senyap, yang RM1 tu dia ambil, dia tak kembalikan. Ada setengah macam contoh yang saya ingat saya, macam bank rakyat ataupun main bank, dia okey. Dia kalau ada yang terlebih bayar tu, dia akan kembalikan balik. Alright, ada soalan setakat ni? Okay, kalau tak ada, kita pergi ke sequence. Sequence is a function whose domain is a set of all non-negative integers and the range is subset of real numbers. Okay, the domain, remember the domain is a set of all non-negative integers and range is subset of real numbers. So that is the sequence. And dynamical system is the relationship among the terms in a sequence that we did just now, the proportionality. And numerical solution is a table of solutions satisfying the dynamical system, like what we did just now. Right here, this is our numerical solution. This one is our numerical solution. Why? Because we calculate this in numerically by iteration. And this is our dynamical system, the relationship between the sequences. Alright, saya ambil masa 10 minit untuk rehat, and then we can come back at 6:05.
Okay, Doktor.
Okay. Approximating change using difference equation. However, the reality is not as simple. And because why? Because we can say the change in some variable can be some function in f, and also change can happen in discrete time or continuous time. So this is why when we use the differential equation. An example. Okay, let's see this one. Growth of yeast culture over the time. So we are talking about, in this case, the pig the big topic of this one is the population growth of yeast culture. Okay, so let's see. When we plot this one, for example, we observe the population after 7 hours. Observe the population in 7 hours, and then we see the values, and we can see that the change in the biomass. Okay, then we plot this one. This is the yeast. This is from, let's label this one. This is A, and this is B. This is the graph for A, and this is the graph for B. All right. Based on A and B, you can see that if we just extrapolate the graph, it looks like something like this. It looks like that. By this from 0 until 7. Okay, from 0 until 7. So apa yang kita nampak yang macam tu. And then we can see that the change in biomass, you can see that if you put some line right here, just some approximating line, it looks like a straight line. Okay, and then we can see the slope right here. Just take this example. Just take the average value, and then the slope is approximated into 0.5. The change is just 0.5 overall in the overall time period. So when you do this, we can say that Pn plus 1 minus Pn equals to 0.5 P of n. Based on this one, the slope is 0.5. So the future value is P of n plus 0.5 P. So this is 1 plus 0.5. This is 1.5 P. So this is how we get future value multiplied by the 1.5. All right. Now, what's the problem for this equation? So you can see that the growth of yeast culture, if you understand, the yeast culture is limited. The space is limited. Let's say consider a petri dish, something like this. Consider a petri dish. So if you have some yeast culture inside this one, okay, imagine like if human are in one place, a confined place yang tertutup, dalam tempat yang tertutup, lama-lama akan terjadi pergaduhan apa semua, dan dia akan macam bergaduh lah. Dia akan bergaduh, mungkin dia nak mendapatkan tempat dan sebagainya. So dia tak logik kalau dari segi kita punya pemahaman pun akan ada there will be some kind of death and so on. So mesti ada populasi yang mati. So dia takkan terus exponentially increase over the time period. Okay, macam mana kita nak buktikan benda ni? So kita cuba try take more values. So just now what we did is until this point. Sampai setakat ni saja. So we only take until this point. So you can see the difference. If we take more data, the difference is quite astounding. So kalau kita tengok kat sini, ada satu tahap, ada satu masa during the time period that the growth is stagnant. Dia tak menaik. Dia jadi macam a flat. Dia jadi flat line. Dan kalau disebabkan oleh apa? This is called because of the carrying capacity. Maksimum benda tu boleh tahan. So the maximum yang apa ni dalam culture tu yang boleh tahan. So if you go past that point, it will be no more increase in the population. It can be a decrease. So bila ada maklumat yang baru ni, maklumat yang terbaru dia kata apa? It will be an increase and somehow it will be a decrease, a small decrease. And then it will be a flat line or maybe a decrease another one. Okay. Why? Because this is constrained. The growth is constrained by the resources. Dia orang yeast ni, bakteria ni dia nak makan, so dia nak berebut makanan, so mungkin dalam perbuatan makanan tu ada yang tak cukup makan, jadi mati dan sebagainya. So things happen, and you can see that, nampak tak dia punya ni lebih berterabur daripada yang ni. So you can see this graph right here compared to this one. Okay. Dia punya data tu agak berterabur sedikit, tapi kalau kita nampak pun dia punya ni you can see that this one can also be approximated by a straight line. Sama, kita kata apa tadi? Point yang saya nak buat kat sini adalah the point that I'm going to claim right here is that you need to make a relationship between two variables. What kind of relationship? Is it a positive relationship or is it going to be a negative relationship? Okay, so the relationship, if we are considering proportionality, the relationship will be a linear. It can be nonlinear, but so far we are considering a linear relationship. Okay, so what does it mean by this one? It means that this is called something. So if you do something like this and you just the model refinement, so refine. So if you go back to right here, first of all, this is from your simplification by assumption. And if you take more data to refine your problem or your model, and then you can see the difference. So this is the prediction, this is from your model, and this is from your observation, from the experiment or empirical study. Okay, and it looks almost close to the exact values. All right, let me see. Ini apa dia maksudnya? This highlight this inside here. This is called the carrying capacity. Okay, so that is called the carrying capacity maximum yang dia boleh ambil, the maximum population yang dia boleh contain. So that one, if the population goes beyond that point, it will be a negative change. So maksudnya apa? Dia punya population tu menurun. Negative change meaning the population is going to be decreased. So from this, this is approximated as this one, 665. And this one. So actually, this one is becoming what? This one is actually a non-linear. The relationship between the variables is no longer a linear. Because why? Let me take this one. What is the value? Pn. Okay. Why do I explain like that? So Pn plus 1, let's say this is the rate of Pn. Okay, but this rate is depending on the carrying capacity. Depend on carrying capacity. What does it mean by that? Okay, so maksudnya kata saya dah kata tadi, kalau dia menghampiri dia punya carrying capacity, the change is going to be slowly goes to zero. Maksudnya the change tu lama-lama dia akan jadi kosong. So dia punya delta P ni, so this is the change. So between this one, and you can see that this two is almost zero, and then eventually it can be a negative. Okay, so this rate is depend on the carrying capacity, meaning that when the population is going to close to the carrying capacity, the change is going to be smaller and smaller until zero. So I can use this, something like this. So the R right now is something like this, something like K minus the carrying capacity. Let's use, I'm going to use N minus Pn times Pn. So this is going to be my new proportionality formula, and K times N minus Pn, this is my new R. Now you can see that from this equation, N minus Pn, when Pn, if Pn goes to close to N, the change in R, not the change, R is going to go to zero. The change is going to go to zero. So the whole thing is R. So now this is no longer a linear proportionality. This is going to be a non-linear proportionality. And by the way, this is called the logistic growth. This is called the logistic growth. It has a limit, not absolute exponential growth, because if you're considering exponential growth, meaning that the population is going to continue increasing exponentially, which is not exactly replicate the real world behavior. All right, now let's see this contagious disease. Suppose that there are 400 students in college dormitory. So we have 400 students, and one or more students has severe case of flu, and IN represent number of infected students after n times period. So we have IN as our variable, and n is the time period, and there will be some interaction between those infected and those who do not infected. And if all of the students are susceptible to the disease, for example, this is an example when we do apa ni dia punya yang DG Hisham tu kata kalau tak apa ni semua orang kalau tak vaksin, everybody is susceptible to the COVID-19 and so on. Okay, so in that case, for example, we have 400 population, and those who are susceptible but not yet infected is this. So if we listed, this is something like this, IN is the infected student. And then 400 minus IN is the remaining. Remaining healthy students. So then if you want to find the this one, if we say this is the assumption if those infected remain contagious, meaning that after 14 days, there are still probability of going to be contagious to other people. Okay, so this is one of the assumption. Kalau kita tak buat assumption tu, kita kena consider another variables to be added, something like here, or minus, plus, or minus. Dia kena tolak orang yang dah sihat. Okay, so dia kena tolak orang yang dah sihat. So kalau kita assume yang semua yang dah kena berjangkit tu takkan sembuh-sembuh, macam itulah maksudnya. So dia kekal dalam keadaan tidak sembuh. So kita punya change, modeling the change of this contagious disease is like this. So it's the same thing as what we done before. So apa maksudnya kalau tengok kat sini, KIN, this is the same thing. Let's say this is like R of IN. R is the rate that is based on the carrying capacity, because the maximum people can be infected is 400. If all students are infected, then the change is going to be 0. Kalau semua orang dah terkena virus ni, so 400 tolak dengan orang yang dah infected tu, semua jadi 400. So dia tak ada lagi perubahan lah. So maksudnya the change is going to be 0. The future value is not to be affected anymore sebab dah semua orang dah kena. So in that case, this is going to be the same that we did for this equation yang soalannya ni, where we have growth in yeast culture. Dia ada restriction on the population. Dia tak boleh nak membiak lagi. Sekejap sebab ada seorang ni tak boleh nak masuk. Saya nak pause share. Okay. So kita ada apa tadi? So based on that, when we refine our model based on the situation of what? Situation because we have a limited resources, or we have a limited amount of population that can be infected. We have something that is limitation to the problem. So you need to change how you define your change. The change in your variables. So in that case, in our case, if we have something like this, the maximum value, so maximum minus, you cannot do vice versa. For example, I minus 400, that doesn't make sense. Mathematically doesn't make sense because the maximum is 400. This is your maximum. Okay, and also I took this from the Worldometers info example from COVID-19. You can see that because of perhaps this is due to what? Due to the SOP, and also due to some vaccination and so on. You can see that there will be this one is like a sharp increase, and this looks like our carrying capacity and so on. Actually, it will be increases and more, because I think the value of infected is currently 2,000, something like that. The total infected, this because that one is not including the total which has been cured and so on. Ini yang jumlah kita ambil yang apa ni, infected. and daily new cases. You can see that this is the first wave, second wave, and the third wave. So you can see how the policies of government policies going to be playing a big role in determining this one, determining this, the wave is going to be increased or decreased and so on. Also some examples. Okay, just now we talk about the discrete change, meaning that we are talking about the change in discrete time. So when we say difference equation, usually we talk about change in discrete time from one hour, the next hour, and the next hour, and so on. It's not like really continuous time. And you can also see that the data is in discrete. Usually, if we're talking about the data, it is always a discrete data. Okay, now let's see this one, continuous change. An example of this is a cooling of an object. Consider a can of cold drink is taken from a refrigerator and placed in a warm temperature, in a warm room, and its temperature is periodically measured. So you measure that at each time frame. The temperature of the drink initially at 40 Fahrenheit, I'm using Fahrenheit. It's okay. You can, if you want to change this to Celsius, that is also not a problem. So the temperature initially is at 40 Fahrenheit and the room temperature is 72 Fahrenheit. And temperature is a measure of energy per unit volume. Energy per unit volume, meaning that if the volume is small, okay, the amount that is contained, the energy amount that is contained inside a body or something is going to be small. If the unit volume is big, if the volume is big, then the amount of energy inside that body is going to be big. So that's why that is why temperature, if you have 1 liter of 1 liter of hot drinks compared to 1 milliliter, it's different. 1 liter versus 1 milliliter of hot drinks. Okay, so that's why it is easy for this one, for this 1 ml compared to the 1 liter. This one is easier to be cooled off because the energy that is contained is small. So there is just some physics of that. And then the room temperature is assumed to not change because of this. Because of this small drink, the temperature, it's not going to change because of due to the small volume. And therefore, the temperature within the can is assumed to not vary. So this is our assumption. What does it mean by this? So for example, if I have this can, let's say this is, Pepsi or something. So the temperature right here, let's say this is T of I versus temperature right here, T of I plus, let's say 4 or something like that. So Ti and then Ti plus 4 is going to be the same. So this is like one whole lump of temperature. So it does not vary. Otherwise, it's going to be complicated if you consider it to be very. And you change that, your expectation is that the change in temperature per time period, the change in, the change in the temperature per time period is large when the temperature difference between the can and temperature is large, and also vice versa. So this is from what? This is from your observation or from the previous observation. Or you can say this is like mechanistic mechanistic studies or deterministic modeling, because deterministic modeling is based on previous knowledge, is based on the knowledge that you know. Change in temperature per time period is large when the temperature between the can and the room temperature is large, and also so on. So what does it mean by this? So let's say my drink right here is 4 degrees Celsius, and then my room is going to be, let's say if I put an aircon, AC room, and the temperature is 16 degrees Celsius, Okay, this is one example. Versus for the same amount, for the same reading of temperature, let's say it's the same thing for 4 degrees Celsius, but the room temperature right now is 20, not 27, I think right now it's going to be 35 degrees Celsius. So the change in temperature for time period is large when the temperature difference is large. So this is what does it mean. So you can see that the change in temperature right here is small, and the change in the temperature between the room and then the can is large, is big. So let's see, the change in the temperature is proportional to the difference in the temperature. This is from the deterministic. The change in temperature is proportional to the difference in the temperature. So meaning that if based on this one, the change in temperature, if the temperature is big, the change is big. If the temperature change is small, the change is going to be small. Okay, so that is proportional. So what you can say that because this is Y72, because the equilibrium temperature is based on the room temperature, because the room temperature is this. The room temperature is assumed to not change, because the volume of a small can is quite small compared to the room temperature. So we can say this is our maximum that the temperature can take. So it is like a temperature at equilibrium. Both are going to, it's going to reach the equilibrium point. No more changing. So that is meant by equilibrium. Okay. And you can see that. Okay, some constant times some constant K times the change in the temperature, and then the starting T naught is equal to 40. And model refinement. What can you refine on this model? Apa yang kita boleh refine? Cooling of an object. For example, you can also say that you can also that say if we put ice or something like this, put ice, and then see the behavior and so on. So usually this one is used to what? This is used to determine how long something is placed on specific position or specific place. Contoh yang paling mudah, example yang kat sini, kalau how to determine the time of death, masa kematian. Berdasarkan apa dia? Berdasarkan tempat yang ditemui. Contoh kalau orang tu ditemu, kalau ada mayat, polis jumpa mayat tu duduk di luar. Contoh yang paling mudah lah, kalau dalam kes penjenayah kita, dalam kes polis apa semua kan, kalau awak tengok sebenarnya dekat polis PDRM sendiri, seingat saya ada salah seorang daripada Inspam, rasanya Inspam, dia ada kerjasama dengan polis PDRM dalam kes-kes ni untuk tengok, dan polis sendiri pun guna matematik nak kira contohnya matematik, biologi dan so on, semua dia consider. Okey, apa yang kat sini saya nak cakap kat sini, kalau awak tengok yang apa ni yang saya kata tadi kan, yang jenayah criminal minds atau criminal CSI apa semua tu kan. Contoh kalau jumpa dekat Tasik, tapi sebenarnya dia dibunuh tempat lain. Contohnya dibunuh mungkin dalam rumah. So dia punya temperature dekat Tasik tak sama dengan temperature dekat rumah. Tapi macam mana polis dapat detect yang dia dibunuh di tempat yang berlainan. Sama juga kalau setengah tu kalau kita pasang aircon apa semua, dia akan merubah. Kalau bilik tu dipasang aircon, dia akan merubah time frame tu. Dia tak lagi sama macam yang biasa. Contoh je lah. Itu yang paling mudah. Ada banyak lagi ni. Ada banyak lagi ada banyak lagi apa saya nak cakap tadi. Faktor-faktor lain tak semestinya yang tu. Okay, any questions so far? Tak ada. So kalau tak ada, kita teruskan ke modeling method to the next one. Chapter mana? Chapter 3. Okay. So untuk yang bab pertama tadi, dia punya lesson for today, yang first is proportionality. How to get the proportionality? You need to see the data. Yang last part tadi kita ada dia punya sikit-sikit bahagian deterministic. So in short, kalau kita ada data, kita boleh tengok dia punya proportionality. You take more data to refine and then see the behavior and so on. So kalau awak tengok ada banyak data, saya tak boleh tengok data terus dapat formula, contohnya partial, saya nak dapatkan dia punya differential equation, tak boleh terus kita tengok berdasarkan data tu, tak boleh kita terus masukkan kata okay, this one it should be differential equation something like this, tak boleh, sebab kita kena kaji dulu the relationship between the variables. So if you establish the relationship between the variables, then you can formulate the formula between the variables. Kita tengok the behavior between the variables. Tak boleh nak terus kepada formula terus, tak boleh. Dia ada step-step dia. Simplify, simple relationship, proportionality by making assumption. Then if you want to refine, if you have more data, taking the data and see your initial assumption is not right, then you need to refine your model by taking another assumption. Dan kita refine lagi. Sampailah dia until it makes sense and also it's confer to the physical world. Dia betul-betul mewakili kita punya real world. Dia tak semestinya exact. Saya kata tadi, modeling is not exact. It's just an approximate of real world. Alright. Yang sebelum ni apa kita kata? Proportionality is the changes. Okay. Kita nak tahu perubahan tu, kita ada benda-benda yang kita make assumption, which is things that is to neglect. Dynamical system is an increase or decrease the relationship between the between two variables. So we have the set of increase or decrease for the data. Discrete or continuous. Discrete can be in discrete space or in discrete time. Or in most cases, we're talking about discrete time. Change in discrete time or change in space. Yeah, in most cases we are talking about time. Unless we are going to talk about some physical behavior, let's say something like this. Contoh. Okay, contoh macam ni yang paling mudah. Let's say we have a okay, let's say we have this metal, a sheet of metal, and this metal, is subjected to a uniform forces on the left, on the right, and also uniform forces on the left. So let's just assume this is uniform. Okay, so there will be some changes, in this case, changes in the space, also in terms of time. So just if you take that metal sheet and then see the changes in space and also the changes in time. And also we're talking about the forces, acceleration, and so on. So it will be a change in space and also change in time. And that is going to be more complicated. And a numerical solution, we have dependent variables that is depend on the dependent variables. Just now, what we do is the spring mass system. An example of that spring mass system, what happened for the spring, if you put some mass and it will elongate. If you remove the mass, it will contract to its original position and so on. And we talk about the yeast and also the disease and so on. So assumption for this one, in most cases, external or internal force we ignore, because that is going to disturb our solution. Initially ignore. Remember, initially ignore, then after that you can consider when you have established your formula and so on. All right, now the next thing is the scaling factor. This is also a big topic. If I take a model, my model of scale is 1 ratio L, and the surface area, so the length is 1 ratio to L, so 1 L, and then the surface area will be 1 ratio to the L squared, and therefore the volume is 1 L cubed. Okay, an example is of packaging costs. Let's say Y larger, Y large package costs more. Y larger package costs less per gram compared to the small package. Why? It can be true, it can be not true. It depends on the courier services. And what are the factors that contributing to such differences? Why is it happen? what are the dependent variables and what are the independent variables? Is there any other variables? So there is a lot of question to ask. Contoh. For example, below we have listed, this is a possible contributor to the wholesale price. Number one, we are talking about the cost, wholesale cost. So you have to consider almost everything that will be used to produce something, to produce a product. Number one, the cost of production, you call it as A. You produce something. And of course, you want to send your product to somewhere else. So in order, you cannot just give it just like that. You need to put it in some package or something. So the cost of packaging. You need to send it by some courier, by shipping, and so on. So you have to consider the shipping cost. And also you need to consider the packaging material, the packaging, the box that is made. D, packaging material. And you need to relate this to the weight and volume of the packaging. And one thing that is not listed here, the human factor, the amount, salary, and so on. Because salary is based on the how many times it will be shipped and so on. So vehicle is not considered right here. You can consider, but it's going to be too much. You can list any other type of cost, but this is just short list of costs. Ada banyak faktor lagi, tapi kita shortlist je dulu. Okay. So A, B, C, D. So we have four possible contributors. Possible contributors. It's not all, but possible. Okay, now we need to know the relationship between the variables. You need to name the variables that are involved, which are dependent, which are independent. Okay, which are dependent and which are independent. Now, I want to ask you this two: cost of production, cost of packaging, cost of shipping, and so on. Is this, let's say this one and this one, I don't want to ask the specific, like to give you a formula or something. I just want you to see the relationship between the variables. So we have A, B, C, D. In these variables, which are the independent and which are the dependent variables? Pada pendapat awak lah. Tak ada, jangan takut. Tak ada ni pun. Saya tak ada benda yang apa. Kalau salah kita betulkan. Sebab kita nak tahu the relationship between the variables. Investigate, just to investigate the relationship. Saya tak nak solve lagi.
Yang dependent and independent tu between A, B, C, D ke?
Tak kisah. Tak kisah. Adakah these two are dependent of each other, or adakah dia independent of each other? Adakah dia bergantung, sama sekali bergantung, ataupun dia separate? Adakah dia separate separate entity?
Production is probably independent.
Okay.
I think.
Sebab apa? Sebab awak kena ada hujah dia kenapa dia independent.
Hmm, But production is like how the thing is made. So macam dia punya
Memang tak ada
resources
kaitan.
lah.
Dia tak ada kaitan dengan packaging, dia tak ada kaitan kan. Benda tu kita nak, so memanglah tak ada masalah pun. Sebab apa? Sebab bila saya tanya tu awak kena bersedia dengan alasan sendiri. Sebab apa? Cost of production material dia tak bergantung kepada packaging apa semua. Dia benda tu produce something. So produce something, dia akan, cost of production tu mungkin dia akan based on production material, bukan packaging material, production material. Gaji pekerja, jumlah amount hours material yang dibuat, yang tu je. Dia tak ada kaitan dengan shipping, dengan packaging, dengan weight apa semua. Dia cuma cost of production, guna elektrik ke air ke semua. So sememangnya yang ni pun tak ada kaitan, masing-masing tak ada kaitan. Cumanya apa yang saya nak adalah apa maksud saya? So production ABCD ni, so let me balik. A, B, C, D, this is the cost. Cost, these are all independent variables. Dia independent of each other. Dia tidak bergantung. Shipping tu tak bergantung kepada packaging, cost packaging. Dia tak bergantung kepada packaging material dan semua. Kita nak benda tu tak ada. Tetapi apa yang kita kata, so these are independent. So bila dia independent, apa yang dependent? Cost lah. So the cost is a function of A, B, C, D. So the cost is depend on the amount of A, amount of B, C, and D. So in short, kita boleh buat, kita kata buat macam ni. Bukan cosine, ini adalah cost. COST. So mungkin kita boleh kata, let's say the R or something like that is dependent on F, proportional to A, B, and C, and D. We don't know yet. So R is proportional to A, B, C, D, something. But kita tak ada exact clear cut dia punya apa? Formula lagi. Sebab apa? Sebab kita tak ada data. Kita tak boleh nak cakap apa-apa. Kita tak boleh nak explain sebab kita tak ada data. Kalau kita ada data, yes, kita boleh explain. Yes. Macam ada orang nak cakap tapi tak apalah. Oh, patutlah meja saya. Okay. So now I just want you to read this one. And let's take a break and then we can continue at 7:05. Okay, so just during the break, I want to give you a time to think about some of this problem. Okay, is it true that smaller animals has higher heart rate than the bigger animals? Is it true? How to say that if it's true or not? You can see the data. And how to verify it, and why is it important for this finding? Because we are not biologists, we don't know why. We can ask somebody from the biology department or from the from the apa nama veterinary department and so on. Why is it important? And free fall, how to slow down the falling speed? What's the difference between someone is heavy or someone is light? What happen if they fall from something? So the question is, how does a weight play a crucial role in its speed and so on? Actually, just for your information, this one, does weight play a crucial role in the speed when for free fall? No, it's the same thing. If someone is bigger or if someone is small, the speed is going to be the same. If you put a bigger like a elephant or kucing ke apa, kalau dia jatuh, dia akan jatuh dalam hierarchy yang sama. Tapi what are the difference? The difference is going to be the impact, the power that it's produced, because power is based on the weight. The momentum is based on the weight. Ya, tak ada masalah untuk speed, dia sama, tapi the difference is the momentum. So that's why, sebab tu kita ada kereta api dia ambil masa yang lama sedikit untuk dia berhenti, dia kena stop, dia kena break awal berbanding dengan kereta biasa. Sama juga dengan lori dan sebagainya. So please be careful, sebab lori dia benda yang berat. So bila benda yang berat, walaupun pada halaju yang sama tapi power dia lain. Okay, I just want to say some comment about that. Power and speed, they are different, but the power is based on the speed and also based on the weight of something. Why some countries have different sizes of banknotes and some don't? For example, Malaysia, we have 10 ringgit is the size is not the same as 20 ringgit, and same thing for 1 ringgit. Kan, tapi kalau awak pergi US, semua duit dia sama, $5, $1, $100, semua dia punya size tu sama. Dan kadang-kadang kita mungkin boleh tertukar. Kenapa dia tak buat benda yang sama? Kenapa dia tidak membezakan size tu? Mungkin ada alasan dia sendiri. Dan soalan yang satu lagi, yang terakhir. Betul ke, did you really save on gas? Dekat duit minyak petrol if driving with closed window. Betul ke? Betul ke kalau kita buka aircon, kita boleh kalau kita tutup aircon, kita akan jimatkan petrol, akan jimat minyak. Okay. So that is one example. Okay. So for today's lesson, apa yang kita nak, yang the next one, this last hour, we want to find the types of behavior. We want to find out the types of behavior based on the solution, based on data, or based on existing theory. And then we use that solution or we use that behavior to form an equation. So this is the mathematical formulation. So based on from data, based on theory, then we formulate a mathematical formulation. And we form the equation. So how to build a model? First of all, you need to know what is it that you want to know. If you want to formulate the problem, what is it that you want to know? Then you need to outline the model. What is the important part and what are the most unimportant part? So this is where our assumption. I always say like this because why? When you do try to solve something, there should be always an assumption. You can also understand this as scope of your problem. Scope dia kat mana? Awak tak boleh pergi melepasi scope tu. Kita ambil model yang kat sini sahaja. Contohnya kalau model denggi di Malaysia, denggi di Malaysia. Kita tidak bercakap tentang denggi dekat Filipina ataupun denggi dekat Indonesia. Kita tak cakap pasal tempat lain. Kita cuma cakap tempat tertentu. Sebab apa? Sebab kita nak memudahkan kita punya calculation or computation. Okay. And is this useful? This thing, the variable, the assumption, is it useful? Or the data, is it useful? The model, and so on. And can you really use that data for prediction? Okay. Dan dia tak semestinya accurate. Contohnya kemungkinan kita ada kesilapan dalam ni, tapi not too much an error. Tak terlalu banyak error. As long as you think that within reasonable apa ni, dalam kes yang reasonable, so tak ada masalah, kita boleh ambil data tu. Okay, and then testing the model. Testing the model maksudnya contoh, you need to consider ethic as well. Macam contohnya kalau kita buat dekat survey on human beings, ataupun kita buat sesuatu, kita nak test drugs, apa ni, apa nama, ke apa, dia punya istilah dia tu apa, keberkesanan, the effectiveness of a drugs, effectiveness of vaccination, and so on. So kita nak test kita punya effectiveness tu kepada manusia ataupun kepada haiwan ataupun kepada apa-apa benda yang hidup. So you need to consider your ethic. And in that case, kemungkinan awak tak perlu buat eksperimen pun. Kemungkinan kita just make a prediction based on the data or based on your common sense. Tak perlu, contoh yang paling mudah, in terms of finite element method, so this is another example, finite element method. What does it do? They used to use finite element method to model an airplane without any experimentation. They just use computer model based on the finite element method, and then they build the model, they build the aeroplane based on that model. And it's pretty good, actually, almost accurate. Okay, now, first of all, how to formulate your problem. Okay, just now, apa yang kita buat sebelum ni tadi, we based on our formulation, based on the data, and then we see the proportionality between the data. Is it a positive proportionality or is it a negative proportionality? Okay, and from in this is actually almost the same, except that we hypothesize the form of the solution. Kita dah ada macam when you see the behavior, okay, I say this looks like something like a quadratic equation. Okay, and then I think this looks like something like this, and you can see the data and you hypothesize the solution. This is called method of conjecture. Kita rasa macam gut feeling, your gut feeling. And then you take more data in order to reject or accept your hypothesis. Then you see the pattern and discuss the solution. Yang ni kita cuma, apa dia tadi, kita our initial assumption. Kita dah formulate sebelum kita buat relationship tadi, yang apa ni, proportionality tu kita tak buat lagi. Kita tak buat lagi yang tu. Kita tengok dia punya behavior, kita apa, tanggapan yang pertama bila kita tengok data ataupun bila kita tengok behavior of the solution. Okay, contoh yang tadi. So let's take this example of saving account. Okay, so kalau kita tengok tadi, EN saving account, so this is at 1% of interest rate for 1 month. Okay, and I'm going to C++, and then plot the data, let's say for 12 months. Okay. So this is in 1 year or 12 months. And this is in 400 months. I say that is more than 10 years, so on. Okay, so you can see that initially for 1 year, the graph is a linear. So you can say that, okay, this is a linear relationship initially. But you can see that after sometimes, after when n is increased gradually, and you can see that this is like, looks like an exponential behavior. So you see the difference when you take more data, because you know because this is based from your previous knowledge. So this is a linear plot, but when you increase the number of the time period, then you see the difference. Then you see the real behavior of this solution. It is going to be an exponential behavior. So it increases exponentially. Do I know the formula? No. Yeah, excuse me. I know the formula. I know the formula because we have done this before. So, but if you don't have this one, then you can conjecture the supposed problem. It looks like an exponential. Okay, now, what if we examine this algebraically? Do some algebraic manipulation. Okay, so what we do is, first of all, we do something like this. A1 is just the rate, this one from this one. Okay, so this is like the rate, and this A naught. Okay, and the next thing is the rate times A1, and A1 is the rate times A naught. So that's why we have R squared times A naught. Same thing, you can see that the previous A3 R times A2. And if we go on, so this is R. A2 is what? A2 is R squared times A naught. So R squared plus R squared times R, it becomes R cubed times A naught, and so on. So you can see that the formula looks something like this. If you go on and do some by induction, and it will be true for K, so it will be true for K equals to n plus 1. Okay, so this looks like what? Yes, it is exponential. This is look like an exponential. So this is like a base. So this looks like A of K equals to B to the power of K times A naught. Doesn't that looks like an exponential function, exponential formula? Because we have some base and then to the power of K. All right. And we can test the formula. We can test the formula by substituting any values. So you can just substitute and see that the formula is right. So substitute an equals to, this is your definition from this one. This is my definition. This one. Okay, then plug in the values. You can see that this is like an, and expand this. So I expand this. This is if I put more step right here, it will be 1.01. to the power of n times 1.01, something like this, okay, because n plus 1 is just multiplied by that to the power of 1, and then this is 1000. So it's the same thing. So you can see that this is proved. Okay, so what's the advantage of this one? The advantage compared to the previous proportionality or the difference equation that we did before, this formula, so A of k equals to, let's say, R of k times A naught, okay, this formula allows us to calculate specific balance at certain times. Compared to what we did before, is what? I say because we have a discrete time frame. So let's say this is let's use this is n plus 1. This is n minus 1, and then n plus 1 and plus 2. So this way, in order to get n, if you are right here, okay, you can only go to this value. You can only go to the next value if you are using the formula of change an plus 1 equals to an plus delta a. If you want to use this formula, then you can only go one step at a time. And if you want to go to this step, n plus 1, this is impossible. You need to know the previous step before you go on to the next step. So you have to do it by iteration. However, the advantage of this formula is that you only need the initial value. As long as you know what's the rate will be and what's the specific time frame that you want to find. So just fine. And you can see the long-term behavior also from this one. You can see this easily because it looks like an exponential. Okay. So the summary of this one is, first one, you observe the pattern. So observe the pattern, conjecture the form of solution, and test the conjecture by substitution, accept or reject based on substitution or by the algebraic manipulation. And for substitution, the result must be identity. What does it mean by that? If you if you substitute any value, then it should be the same. It should be the same. Okay, so let me repeat that again. So you observe the pattern. For example, this one is linear. Okay, so for the first thing, okay, you say this is linear, that's okay. But you take more data. Now it looks like an exponential. Okay, you say that it looks like an exponential. And then you see the algebraic manipulation and get the formula. Then test the formula by substituting, and then you can see that it is exponential. Plug in the values. I didn't plug in, but you can try to plug in the values, and you can see that the solution is exactly the same. Okay. So in general, I'm going to be 10 more minutes, then I'm going to stop because we have a quiz today. Don't worry, it's a simple quiz. It's not a difficult one. Okay, what if? Let's see. What if in general case, R can be any values. R can be negative or R can be positive. Okay, so first of all, we look for the pattern of this formula. Okay, so you can see that A3 and R3, A0 and R0. So you can say A of K equals to R of K times A0 in general case. And we substitute this equation and you can see this is the same thing. So this is our formula for that particular case. For this particular, for this particular proportionality. It can be the same, it can be different. For example, what happens if you withdraw something, if you take some value each month, constant amount, and then it's going to be the different. Okay, but so far, just take a simple one. All right. So in summary, if we have this system, if we have this set of dynamical system, set of data right here, and for R, any non-zero constant, the formula is like this. So this is our formula. So if the future value is increased or decreased by a constant rate, then the whole formula or the whole solution is going to be, the solution of this system is going to be AK equals to R to the power of K in a exponential function. Okay, now let's see this one example. So far, any questions so far? Okay, I presume that there will be no question. That's quite straightforward, right? So I'm just going to repeat what we have, what I've said. First of all, what we did is we create a proportionality by using and then see the difference. What do you call it? Difference equation. Okay, the difference equation, create the difference equation, and then for the whole time frame you need to find using the iteration process. But for the next step, we see the whole idea by looking at the behavior, and we can conjecture the solution, what kind of problem, what kind of solution is going to have, and test your formula by substituting and then by some algebraic manipulation and see how it works. And does it make sense? The formula, does it make sense? All right, now let's see an example. A sewage treatment plant processes raw sewage to produce usable fertilizer. So dia nak guna baja. And by removing all other contaminants, so this is going to process removing the contaminant, and the process is that at each hour, for each hour, 12% of remaining contaminant in a processing tank are removed. So each hour, 12% of that is going to be removed. Every hour is going to be removed. So what percentage of that sewage will remain after 1 day? So 1 day meaning 24 hours. How long will it take to lower the amount of sewage by half? So meaning that we are going to find the T, the percentage of that. And how long until the level of sewage is down to, cannot read that one. How long? 10% of the original level. So this is related to the rate. So something that is removed. So you can understand that as it looks like the mortgage curve. Okay, now if we take this one, take this and then plot this one. Okay, let's say the C This is just my assumption. Okay, let's say we start with concentration. C is the concentration. C is initially at 10 concentration. And this 88, 12% is removed every hour. Okay, 12% is removed every hour, meaning that, so therefore, by your understanding, it will be 88% is remain every hour. So that's why we have right here. So the new value, so this is the same thing that is we did before. So we have something like this. C, because I'm using I equals to 1 starting from, because for C++ or for C, the index start from 0. So I'm fine with I minus 1. If you are using MATLAB, index start with 1, so you cannot do like this. Okay, so what I'm doing is that this is like C of I equals to R of what? Of Ci minus 1. That is going to be the same thing as this is equivalent to something like this, Ci plus 1 equals to R Ci. As long as you understand the difference right here, or the similarity of that, that is going to be not a problem. Or you can understand that see the change is you can also plot this using like this, delta C equals to C and I minus Ci, C of n, something like that. So which one you can start, it's not a problem. Okay. All right, now you can see that after what? After this is 10 hours and it will go to almost 0. Okay, any question on this? So actually this one is already answered the solution. Let's say what percentage would remain after 1 day. So in this case, after 10 hours, 100%. So there's only 0% remain. The concentration is almost 0. And you can see that how long will it take to lower the amount of sewage by half? So just 10 by half is just 5. You can see this is going to be almost like a 6 hours. And this one, how long until the level of sewage is down to 10%? So 10% of the original amount. So you can do the calculation, do the math by yourself. See, and then look at which 10% is going to be right here. Okay, so that is, I think this is quite easy. Now let's look at this one. We need to see the behavior at t goes to infinity. Okay, now if r is 1, is the rate is 1. We have 4 cases. Number 1, r is 1, the rate is 1. So you can understand, remember that this is en plus 1 equals to r en. Okay, if rate is if rate is bigger than 1, if rate is less than 1 meaning it can be less than 0, because 1 this way less than 1, it can also include 0, so this is 1. And this one, absolute value, it means that this is a positive but less than 1. For example, if we have 0.5. Okay, now let's see this negative R, this one. Case of negative rate. So this is unstable. The solution is unstable. It's growing. Case where we have positive, but the value is between 0 and 1. So the rate is like 0.01, something like that. So in this case, this is stable, and the solution is going to be 0 when t goes to infinity. And if we have a small value, a small percentage between, this is negative, but less than -1, negative but less than 1, meaning that, for example, if we have negative 0.01, okay, so initially it will be unstable and then it will stabilize. Okay, now I want to ask you, why do you think that when R is less than 1, let's say -2, why do you think that the behavior looks like this? Now you need to relate an plus 1 equals to R of an. Why do you think the solution looks like this? Rasa-rasa kenapa? Ya, rasa-rasa kenapa dia jadi macam ni? Kalau dia negatif, okey, tak tahu, tak ada jawapan. Okey, kalau tak ada jawapan tak apa. Saya tak tahu, saya tak pasti awak ada ke tak kat depan ni sebab saya tak nampak muka. Okey, saya akan bawa ni kepada minggu depan. Nanti kita bincang minggu depan kenapa dia punya cases ni bila macam ni dia jadi, bila R is negative it becomes like this. Okay, so saya akan berhenti kat sini sebab apa? Sebab saya nak bagi laluan kepada quiz number 1. Okay.